So topic photoelectric effect. Light is shown onto a metal surface. The photoelectrons are emitted out. Basically what happened, the light in the form of packets, photons, when energy of a photon is greater than and equal to the work function, minimum possible energy, remove the electron. So these electrons will come out and they will have a kinetic energy. So explain the photoelectric effect. What is basically photoelectric effect? When light in the form of photon absorbed by the electrons will come out if the energy of a photon is more than the work function. This effect is known as photoelectric effect. So you have to explain the photoelectric effect. When light in the form of photon absorbed by the electrons, if the energy of the photon is more than the work function minimum possible energy to remove electron, this electron will go out. The part B, the maximum kinetic energy of photoelectron is determined from a range of frequencies of incident light. The results are shown. We are changing a frequency and the maximum kinetic energy is also increasing. Use the graph. We have to calculate the value for the Planck's constant. So how we can work out the value of the Planck's constant? We have the formula because we are plotting kinetic energy on y-axis and we are calculating frequency on x-axis. So when kinetic energy on y-axis and frequency on x-axis, the gradient will give us the Planck's constant. So we'll find the gradient of this line. It will be y2 minus y1 over x2 minus x1. So take any points. You can take the first point, like that is 4. This one is 0. You can take the maximum value. Say 2.2 is there, and this one is look like 7.4. So 7.4 is there, 4 is there, 0 and 2.2. So y2 minus y1, the gradient of this graph, whenever it is frequency and the kinetic energy, the gradient of this line will give us the value of the Planck's constant. Describe the significance of a frequency of a light having a value of 4 exponent 14 hertz in this experiment. So as you can see, before 4 exponent 14 hertz, there was no photoelectric effect. So that is the lowest or a minimum frequency, which we also call a threshold frequency. So if a frequency of a light below this level, it will have a low energy. So the kinetic energy of photoelectron will be 0 or no photoelectric effect. So if the energy of this is called a threshold frequency. So this is refers to a threshold frequency or minimum possible frequency to remove electron from the metal surface. And if the energy of the photo that is low, it means it will be less. The energy of photon will also be less, so there will be no photoelectric effect. Below this, and if it is equals to 4 exponent 14, there will be a photoelectric effect, like electron just come towards the surface, but it will not have enough kinetic energy to move. Then calculate a work function of the metal in electron volt. So using this frequency, we'll work out because that is the minimum possible frequency. So we'll work out the work function. The work function will be h and f naught. This will give us, using this frequency, the minimum possible frequency, we multiply by Planck's constant, we'll get work function. And if the kinetic energy is 0, because when the energy of the incident photon is equals to the work function, then the kinetic energy of the electron will be 0. So first we'll find the energy in joules and then we'll convert. So the formula which we use, or a formula which we relate, so the work function is equals to hf, and that work function will be equal to the, like the using a frequency, we work out the work function, the minimum possible energy needed to remove electron, and using this value will work like this will directly give us the work function. So phi is equals to the value of the Planck's constant, which is 6.64 in 6.63 into 10 to the power minus or 6.4 into 10 to the power minus 34. Or this will be 6.63, sorry, into 10 to the power minus 34, the Planck's constant times the minimum possible frequency, the threshold frequency we multiply, we'll get the answer in joule, 2.65 into 10 to the power minus 19 of the joules. But now we have to convert into electron volt. So we know 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if we have 2.65 into 10 to the power minus 19 joules, it will be x electron volts. We cross multiply. It will give us the work function around 1.56 electron volt. So this is the answer in joules, the value of a work function in joule, and then we convert into electron volts.